In my last video, I talked about product and quotient two. So if you don't understand it about product two and quotient two, you can watch my past video. So now in this video, I'm talking about logarithm, logarithm, logarithm function. That's logarithm with derivative. So let's just go straight to the point. So the formula for calculating how to differentiate logarithm function, the formula how to differentiate is very simple. The y dx is equal to the first derivative of what function over what function is power x. That's function of what x. So this one for calculating what on how to differentiate logarithm what function. In every derivative you have different formula. Chain has its own formula, quotient two has its own formula, product two has its own formula, and so many other rules has their own what formula. So for logarithm rule, this is formula for calculating what logarithm what rule. So let's pick a question. Let's say you have y is equal to ln x all over what 1 minus what s squared, right? So based on this question, our function of x is what this, that's x over what 1 minus what x squared is equal to. So to get our first derivative, this means that differentiate this and you get this. In calculus, whenever I see this sign, maybe you see whenever I see this sign, you see this sign it means first derivative. This sign it means second what derivative. It means differentiate it what twice. Continue, it means differentiate it what three times. So our first derivative. So differentiate this. Look at this question. What tool are we going to use to differentiate this? Based on my past video, we're going to use what quotient two. So quotient two formula is v du dx minus what u dv dx all over what v squared, right? So this is our u and this is our v. My u is what x, my v is what 1 minus s squared, v is what 1 minus what s squared. So we have our u, we have our v. So to get our du dx and dv dx, my du dx here, du dx is what du dx means differentiate u with respect to x. In our last video I explained everything, so this which is what 1. My dv dx is what minus what 2x. It is equal what minus 2x. So now let me put this into our formula. So into our formula we have v as what 1 minus s squared close bracket, then du dx is what 1 minus what's our u x open bracket, what's our dv dx, dv dx is what minus 2x all over, my v is what 1 minus s squared, that's 1 minus s squared plus 2 is power 2. So now that we put our formula, so let's simplify it. Then we have this times this will give us what 1 minus what s squared minus x times minus 2x, that's plus 2s squared all over what 1 minus s squared all over what is power 2. Now our first derivative is based on this minus s squared plus 2s squared is what, that's plus s squared, that's 1 plus s squared all over what 1 minus what s squared is power 2. So these are what first derivative. Now let's input this to our logarithm what formula then to differentiate using what logarithm. So we put this to our formula for calculating logarithm. So logarithm formula is what dy dx is equals to the first derivative all over the function of x. So what's our first derivative? So our first derivative 1 plus s squared all over what 1 minus what s squared plus power 2 all over what the function of x is what x all over 1 minus s squared x all over what 1 minus what s squared. This can be written as 1 plus s squared all over 1 minus s squared divided by x over what 1 minus what s squared, right? So let's break it down using our what normal mathematics. So you break this down, you have 1 plus s squared all over what 1 minus s squared raised to power 2 times this 1 minus s squared over what x, right? So this will cut out this means 1 minus s squared appear what twice. So this cut out this thing, it means what 1 minus s squared. So therefore this times 1 is 1 plus s squared over x bracket 1 minus what s squared. So this is answer for that question. It's very simple. Just know how to solve, just know the formula, then follow the step. Just watch my beginning video, chain rule, product to quotient two, and first principle. Learn everything, then you can learn. Then once you learn that, you can solve this logarithm question. Because logarithm question requires you to solve, to differentiate using others rules. So let's go to the last question. So for the last question, let's say we have number 2. We have y equals to log e. This is log bz, right? Let me write it well. Sorry for that. Y is equals to log bz 4x minus 1 is power 2. So now I'll give this question, differentiate it. Very simple. So we know that our logarithm formula is dy dx equals to the first derivative of the function of what x, right? So what's our function? Our function is 4x minus 1 all squared, right? So this is our function. So let's differentiate this to get this. So differentiate this, our first derivative. We have look at this question now. So what method, what we are going to use to differentiate this? Is it quotient 2, is it product 2, is it chain rule, or the first principle? In this we are using what? Chain rule. So using chain rule, let's say using chain rule. This is our u, right? 4x minus 1. Then our y is equals to what? U is power 2, right? So if differentiate du dx, that's du dx is equals to 4. Then dy du is equals to what? 2u. Remember that chain formula is dy dx is equals to dy du times du dx, right? So what's our dy du? 2u times what du dx? 4. So that's 8u. So what's our u? Our u here is what? 4x minus 1. That's 4x what? Minus 1. So the first derivative of this is what? This. So that means this is our first what? Derivative. So therefore our first derivative is 8 bracket 4x minus 1 all over the function of x, which is 4x minus 1 raised to power 2. 4x minus 1 raised power 2. So this and this are the same thing, right? So if you cut out this, then it will remain 8 all over 4x minus 1. So therefore this is the answer. I can put brackets. So therefore this is the answer. This x power 2 means 4x minus 1 occurred twice. So there's one here. It won't cut out once, so it means second one. So therefore this is the answer we're calculating for demonstrating this question. Thank you.